Hello, this is Mrs. Boots, and we're going to work our practice problems for solving radical inequalities. Remember, there are two parts. In the first part, we solved the exact same way we solved a regular radical equation, the IRS method. We need to isolate the radical. So my square root of x plus 5 needs to be by itself on one side of the equation. In order to accomplish that, I have to add 1 to both sides. So I get the square root of x plus 5 is less than or equal to 5. Now, I have to get rid of the radical. We need to raise it to the power. Since it's a square root, I'm going to square both sides. When I square, the square root and the square cancel, leaving just the x plus 5, the stuff inside the radical. Less than or equal to, well, 5 squared is 25. Now I can solve for the x. Subtract 5 from both sides and I get x less than 20. Remember, this is only half of the answer. I now have to find the other half. So we have to do part 2. Part 2, I take the stuff inside the radical, x plus 5, and set it greater than or equal to 0. Now we just solve for x. So I would subtract 5, leaving x greater than or equal to negative 5. Now let's put both of these values on the number line. The negative 5 goes on the left and is going to have a solid dot because it has the equal to symbol. The 20 goes on the right and also gets a solid dot because it has an equal to symbol. Now which way do we shade? For the 20, I'm going to shade to the left. And for the negative 5, I shade to the right. So my shading ends up all in the middle. If we wrote this solution in interval notation, we would write it as square bracket, negative 5, comma, 20 with another square bracket. Number 2, we do the exact same thing. Part 1, IRS. Isolate, raise to the power, and solve. Isolating the radical, I need to move the positive 6. So I subtract 6 from both sides. This leaves the square root of 2x less than or equal to 4. Now I can raise it to the power. Since it's a square root, I am going to square both sides. I'm left with 2x, because my square and my square root cancel, less than or equal to 16. Now we divide both sides by 2. And we get x is less than or equal to 8. Now let's do part 2. Remember, for part 2, we set the inside, 2x, greater than or equal to 0. Because it's a square root, it cannot be negative for our graph. If it were a cube root, we wouldn't have to do this part because those can be negative. For the square root, we have to do greater than or equal to 0. Well, this is relatively easy. We simply divide both sides by 2, and we get x is greater than or equal to 0. Now let's put both values on the number line. The 0 comes first on the left and is going to have a solid dot. And on the right, we have our 8. It also has a solid dot. The 8 is going to shade to the left, and my 0 shades to the right. So my shading happens in the middle, in between 0 and 8. If I wrote this in interval notation, I would have square bracket 0, comma, 8. Because both of them have closed dots, we would use square brackets. I could also write this in interval notation. In inequality notation. As 0 less than or equal to x less than or equal to 8. Either form is acceptable. Number 3. Is the radical by itself? Yes. So all we have to do is raise it to the power. Because it's a square root, I square both sides. When I square it, the square and the square root cancel, leaving 2x plus 5. All the stuff inside the radical. That's going to be less than 5 squared. 5 squared is 25. Now let's solve for x. I'm going to subtract 5 from both sides. That gives me 2x less than 20. Now we can divide by the 2 in front, and that leaves us with x less than 10. Remember, if we had divided by a negative number, we needed to flip the inequality symbol. In this case, we do not. Now let's look at the part 2. I take the stuff under the radical, 2x plus 5. Only now that quantity has to be greater than or equal to 0. So we still subtract the 5 from both sides. So we're left with 2x greater than or equal to negative 5, and then we're going to divide by 2. So x is greater than or equal to, yes, you can convert to decimals, negative 2.5. Okay, so let's put those on the number line. The negative has to go on the left. Negative 2.5. Alright, it's going to have a solid dot because it has an equal to. Now we put the 10 on the number line. The 10 has an open dot because it's not equal to. Now let's figure out which way to shade. From the 10, we shade to the left, and from the negative 2.5, we're shading to the right. So all my shading happens where the arrows overlap, which is in the middle. So my solution would be a square bracket, negative 2.5, comma, 10 with a parenthesis. Number 4, isolate the radical. Well, my radical is isolated in this part, so I can jump straight to the next step, which is to square both sides. We're raising it to the power. Now, the square and the square root cancel, leaving 8x plus 1 greater than 7 squared, which is 49. Now we solve for x. Minus 1 minus 1. So I have 8x is greater than 48. Now what do? We always divide by the coefficient in front of x because I want x by itself. So x is greater than, what's 48 divided by 8? 6. So part 1 is done. Now we have to do part 2. Take the stuff inside the radical, 8x plus 1, and set it greater than or equal to 0. Again, you solve for x. Minus 1 minus 1. I get 8x is greater than or equal to negative 1. Then we divide by 8. Always divide by the number in front of the x. And we get x is greater than or equal to negative 1 over 8. You don't have to get a decimal value unless the fraction makes you really uncomfortable. Negatives go on the left. Negative 1 over 8. It has a solid dot because of the line underneath. The 6 goes on the right because it's positive. Has an open dot because it's not equal to. From the 6, I shade in the direction the arrow is pointed. And the arrow is pointed to the right. So I'm shading to the right. From the negative 1 divided by 8, I also shade to the right. Now this may be confusing, but ask yourself, from the negative 1/8, it's going to keep going, right? So my overlap is everything that's above the 6. That means my solution goes from 6 to positive infinity. As long as I use those values, I will get a solution. Now we use a parenthesis for the 6 because remember the 6 did not have an equal sign. Number 5. Is the radical alone? No. So I need to add the 1 to both sides. Then we get square root of 5x is less than or equal to 9 plus 1, which is 10. Now my radical's alone, I can raise it to the power. To get rid of a square root, I square both sides. The square and the square root cancel, just leaving the 5x. And 10 squared is 100. Now what do? We have to divide by the number in front of the x. So we get x is less than or equal to 20. 100 divided by 5 is 20. Now let's do part 2. Take the stuff under the radical, 5x. Set it greater than or equal to 0. Then solve. Well, this is a little easier because all I have to do is divide by 5, and I get x has to be greater than or equal to 0. I'm going to put 0 on my number line with a solid dot because it has the equal to. 20 on the right because it's a bigger number, also with a solid dot because it has an equal to. From 20, I'm going to shade to the left. That's the direction of the inequality symbol. From the 0, I shade to the right. The arrows for the shading overlap in the middle, in between 0 and 20. I would write this in interval notation as bracket 0, comma 20 with another square bracket. Number 6, is the radical alone? No. So I have to subtract the 9 to move it to the other side. When I subtract the 9, the radical is now by itself. Square root x minus 2 less than or equal to negative 9. Remember, the inequality symbol doesn't change when you add or subtract. To cancel the square root, I'm going to square both sides. Does it matter that the 9's negative? No, we would just put it in parentheses when we square it. So on the left, my square and square root cancel, leaving x minus 2. On the right, 9 squared is 81. Now we can solve for x. Add 2 to both sides. X is less than or equal to 83. Okay, now for part 2. Take the stuff under the radical, x minus 2. Set it greater than or equal to 0. And then solve for x. Add 2 to both sides, and we get x is greater than or equal to 2. Let's put both numbers on the number line. 2 is smaller, so it's going to go on the left. Gets a nice solid dot because the inequality symbol has a line underneath. 83 goes on the right, also getting a solid dot. From 83, my arrow is pointed to the left, and for 2, my arrow is pointed to the right. So my shading occurs in the middle. In interval notation, we would write this as a square bracket with a 2, comma, 83, and another square bracket. Number 7. Is the radical isolated? Yes. That means we can just raise it to the power. So I square both sides. The square and the square root cancel, leaving just the stuff underneath. 2x minus 15. Drop down the inequality symbol, less than 5 squared. Go ahead and simplify that. It's 25. Now let's solve for x. Add the 15 to the other side. How do we know we're adding? That's right, because it is subtracting currently. 2x less than, now add those together, 40. Now we need to get rid of the coefficient in front of the x. That means we divide. So I divide both sides by 2, and I get x is less than 20. Now for the inside, part 2. 2x minus 15 is greater than or equal to 0. Remember, it's always greater than or equal to 0. We need to add the 15 to the other side. Notice it repeats the steps. Some of the steps that we used to solve once we're isolated. So 2x is greater than or equal to 15. Yes, when we divide, 2 does not go into 15 evenly, and we're going to have a decimal. But that's okay. X is greater than or equal to 7.5 or 15 over 2, whichever one you prefer. 7.5 is smaller then 20. So the 7.5 goes on the left. It gets a nice solid dot because of the equal to under the inequality symbol. The 20 goes on the right, but it has an open dot because it doesn't have an equal to symbol. From the 20, I shade to the left. From the 7.5, I shade to the right. So my solution is where the shading overlaps, in the middle, between my 7.5 and the 20. Now remember, when you write it in interval notation, the 20 is going to have a parenthesis, and the 7.5 will have a square bracket. Number 8. Is the radical by itself? Yes. So we can raise it to the power. Square both sides. Now that we've squared both sides, the square and the square root cancel. The 1/2 is completely under the radical, so we can't get rid of the 2 before we square it. That's going to be greater than 49. Remember to square the other side. Now we can solve. Add the 6 to both sides. I get 1/2 x greater than 49 plus 6. That's 55. Now, 1/2 x. How do we get rid of the 1/2? The 2 is dividing. What's the opposite of dividing? Multiply. So I'm going to multiply both sides by 2. My 2 and my 1/2 are going to cancel, leaving just x. I still have my greater than symbol, and 55 times 2 is 110. Now, let's do the inside. What's inside? 1/2 x minus 6 greater than or equal to 0. We still add 6 to both sides. 1/2 x greater than or equal to 6. And yes, we do the exact same thing again. Multiply both sides by 2. The 1/2 and the 2 cancel, leaving just x, which is greater than or equal to 12. Now let's put it on the number line. 12 comes first because it's smaller. Gets a solid dot because it has the equal to. 110 is on the right and has an open dot. The 110, according to the inequality symbol, shades to the right. My 12 also shades to the right. We had a problem like this before. The overlap is going to be far to the right, everything above 110. So I would write parenthesis 110, comma, infinity. Remember, the 110 gets a parenthesis because it does not have the equal to. Number 9. Is the radical by itself? No, it has that 1/2 out front. Remember what we just did in problem 8? The 2 is dividing. The opposite of division is multiplication. So we're going to multiply both sides by 2. The 1/2 and the 2 cancel, leaving just square root of x plus 5 on the left. I still have less than equal to. 4 times 2 is 8. Now that the radical is by itself, I can raise it to a power. Square both sides. Square and the square root cancels, leaving x plus 5. Still have less than equal to. 8 squared is 64. Now solve for x. Minus 5 minus 5. I get x less than equal to 59. Now let's do part 2. Remember, it's only the stuff under the radical. X plus 5. Greater than or equal to 0. And it's always going to be greater than or equal to. I'm going to subtract the 5 in order to solve for my x. I get x is greater than or equal to negative 5. On my number line, negative 5 goes first. It's the smaller number, but it gets a solid dot because it has the equal to. You're always going to have one solid dot. 59 goes on the right because it's bigger. The solid dot is because the part 2 is always greater than or equal to. 59 also gets a solid dot. The 59 is going to shade to the left. and the negative 5 shades to the right. My shading overlaps in the middle. So my solution is every number, including negative 5 and 59, and all the numbers in between. Number 10. Is the radical by itself? No, we have that 3 out front. So we subtract it to get to the other side, right? No, that 3 is actually multiplying. So we do the opposite of multiply, which is divide. We're going to divide both sides by 3. On the left, I would have square root of 2x minus 8 less than 12 divided by 3, which is 4. Now, how is my radical by itself? Yes, square both sides. Raise it to the power. Square and square root cancel, leaving 2x minus 8 less than 4 squared, which is 16. Now we can solve for x. Add 8 to both sides. We add the 8 because it's being subtracted. I'm left with 2x less than, well, what's 16 plus 8? 24. Now we can divide by the coefficient in front of the x, which is a 2. And we get x is less than 12. 24 divided by 2 is 12. Now we do part 2. Take just the stuff under the radical. 2x minus 8. Set it greater than or equal to 0. So I add 8 to the other side. 2x greater than or equal to positive 8. Divide by 2. 2x is greater than or equal to 4. 4 is the smaller number, so it goes on the left and gets the solid dot because it has an equal to. 12 is on the right. It also gets it doesn't get a solid dot. It gets an open dot because it does not have an equal to. From the 12 we shade to the left, and from the 4 we shade to the right. My shading overlaps in the middle, so my solution would be from 4 to 12, but remember the 12 gets a parenthesis because it's not included in the solution set. Number 11. This one's kind of different. I have an x plus 5 under the radical, and the radical is isolated, or x minus 1 on the other side. That's okay. We're just going to put it in parentheses so we can keep it together. Since the radical is isolated, I can raise both sides to the power. I'm going to square it. My square and my square root still cancel, leaving x plus 5. On the other side, because I have a binomial squared, I have to write it twice. X minus 1 times x minus 1. Now, let's simplify. The x plus 5 comes down, less than x squared minus x plus 1. Now, it's a quadratic. We know that because the highest power is 2. That means it has to be equal to 0 in order to solve it. Is mine equal to 0? No. So I have to subtract the x from both sides and subtract the 5. Now we can simplify. 0 less than x squared minus 3x minus 4. This is where it gets a bit tricky. What I like to do is just go ahead and factor. Ignore the inequality symbol and factor it. I need two numbers that multiply to give me 4 and subtract to give me 3. Now it's going to be 4 and 1. Remember, the big number gets the same sign as the middle, and the other number is going to get the opposite because we subtracted. I'm going to ignore the inequality symbol for a moment and solve these. What would x equal to get x plus 1 to be 0? Yes, it would have to be negative 1. What about the x minus 4? That would be positive 4. Those two numbers are going to go on my number line. But wait, we still have part 2. Take the quantity under the radical, x plus 5, and set it greater than or equal to 0. So x has to be greater than or equal to negative 5. Now we put these in order. I have a negative 5 with a closed dot. Then I have a negative 1 with an open dot and a 4 with an open dot. From the negative 5, I know I'm shading to the right. But for the negative 1 and the 4, we're not sure which way we're shading. So let's check. What is a number that's in between negative 1 and 4? A number in between those two would be 0. That's always a good number to check. So let's plug it in. If I've got the square root of 0 plus 5, is that less than 0 minus 1? Well, the square root of 5, that's going to be 2 point something because it's bigger than 4. Is 2 point something less than a negative 1? No. So we're not going to shade right there. Now let's look at the 4. What's above 4? Give me a big number. So I'm going to do 11. Because 11 plus 5 is 16. Okay, so let's plug that in. So the square root of 11 plus 5 is less than 11 minus 1. Okay, 11 plus 5 is 16. Square root of 16 is 4. Is 4 less than 11 minus 1, which is 10? No. So we're not shading in these two areas. That means the only place we can shade is right over here above the 5, but before it gets to the negative 1. So when I write this solution in interval notation, it would be negative 5, comma, negative 1 with a parenthesis. It wouldn't even go up to the 4. Number 12. Let's put those two terms on the other side in parentheses. The radical is by itself, or we're going to go ahead and square it. Both sides. We're left with 10x plus 21 greater than the binomial squared, x plus 2. Remember, when you have a binomial squared, you simply write it twice. Now we need to multiply it out and simplify. So I have x squared plus 2x plus 2x plus 4. Now, same thing as before, it's a quadratic, so I have to move everything to one side in order to be able to factor. So I subtract the 10x and subtract the 31. So I have 0 greater than x squared. 2 plus 2 is 4 minus 10 minus 6x. And negative 31 plus 4 is negative 27. Just as before, ignore the inequality symbol and factor it. So I have x is in the front. Two numbers that multiply to give me 27 and subtract to give me 6. 9 and 3. The 9 would be negative, the 3 would be positive. If I set those equal to 0, I would get x equals 9 and x equals negative 3. Those two numbers will go on our number line. Now let's look at the insides. 10x plus 31. It has to be greater than or equal to 0. So I subtract the 31, and I get negative 3.1. When I divide by 10, I get negative 3. I'm one step ahead of myself. I divide by 10, and I get negative 3.1. Okay, now let's put it on the number line. Negative 3.1 is the most negative number. Then I have the negative 3 and the positive 9. The negative 3 and the positive 9 have open circles, and the negative 3.1 has a closed circle. Now we plug in numbers. I usually do a 0, and in this case, we'll go ahead and do 10. When I plug in 0, I get a check. It is shaded in the middle. Well, we already knew from the 3.1 we were headed to the right. So we know we're going to shade all in here as well. 10, however, doesn't check. So we're not going to shade for 10. So my shading goes from the 3.1 all the way to the 9. So in interval notation, I would put a square bracket, negative 3.1, comma, 9 with a parenthesis.